Let's simulate a three-phase uncontrolled bridge rectifier using Plecs block set. For that, I have opened a Simulink model where we can import the Plecs circuit here. You see, if I just drag and drop a Plecs circuit and double click here, we can build our topology inside that Plecs environment and then simulate. Now the power of Plecs block set is that we can integrate the Simulink libraries and the Plecs libraries. For example, if we want to design a controller in Simulink, we can use that in Simulink environment and then connect it to the power components in Plecs. Now this is going to be a simple tutorial. Let's just look into how to build a three-phase uncontrolled bridge rectifier. So to bring the components to the Plecs environment, we can double click to the components here and we can choose, for example, the source. We need a three-phase source. Drag and drop here. We need diode. I will just remove all the names, so not show the names here. To build the B6 bridge, we just copy it 5 more times. And let's connect the diodes. And to connect the source, let's first modify the amplitude voltage to be 700 volts. Frequency, let's keep 50 and hide the ground symbol. Now I want to measure the input side currents and voltages, and for that we need a three-phase meter. I connect it here. And then phases are connected to the ohms of the bridge. Let's measure the line to line voltage, and for the DC side, let's take a resistor. Let's put a value. Let's take the default 1 ohm and say okay. To measure the DC voltage, let's take a voltmeter. Voltmeter. Okay. And to show the curves, we need to take a scope. Let's take in total 3 windows so that we can take the output, so the input side AC voltages, 3-phase, input side AC currents, and output side DC voltage. Once we are ready here, so it's ready for simulations, let's adjust the parameters. So start time 0, and let's simulate it for 5 periods, that is 5 times 20 milliseconds. For the solver settings, let's keep it to the default settings first, and in case need be, we can change it later as well. So I'll go to simulation and start. As you can see, this is the input side voltage, these are the input side current, and this is the output side DC voltage. Now you see the curves are not so smooth here in this case. So what we need to do, go to the simulation setting again. Let's take a maximum step size to be 10 microseconds. Then I will take the refine factor. Where it is, I need to figure it out. It's a refine factor. Let's take it to be 5 and then rerun the simulation. So now the curves are quite smooth, which is enough for us. Now let's check the values. So we took a peak value of the input side AC voltage to be 700 volts. Is it so? Let's check. It is. So max would be, RMS is 876. Okay. Now the point is the 700 volts as we defined in the source is the amplitude. Now for 3-phase, that's for example an RMS. Say I want to take 700 volt to be the RMS voltage. In that case we need a factor of square root of 2 by 3. Let's check the results now. Yes, you see, if we take the measurement for a couple of periods, we see we have here, if between these two cursors, we have RMS value of 700 volts, which we expect, and the max is 700 square root of, which is 990 volts. Now since we have an uncontrolled bridge, that means the DC side voltage would be 1.35 times the RMS connection voltage, which is 946. Let's quickly check the values in calculator. It's 1.35 times 700, which is 945. In this case, if we see the mean values, it's around 945. So the theoretical calculation here is in order of the formulas. Thank you for watching.